Hello, everyone, and welcome to a new week of learning in general mathematics. So before we move on with the main topic for week 2, let me first have the slides for you to recall what we had on the first week. Okay, so I have here the problem. Write a function C that represent the cost of buying alcohol A if an alcohol costs 155 pesos. So if you can still remember, this is under the first topic last week, which is how to represent real life situations as a function. So as I have mentioned to last week's online class, when we deal with function, you need to think of a formula that is suited to the given problem. So in this case, you need to think of a formula that if you're going to buy, let's say, for example, 5 alcohol or 5 bottles of alcohol. So how much are you going to pay? So how will you do that? Okay, so of course, to do that, you need to have the formula C of A, which is a function, is equal to 155A. And A here deals with the number of bottles. Okay, so as I have mentioned, if you'll buy 5 bottles, then you will have 155 times 5. So that will be the total cost of buying 5 bottles of alcohol. Okay, let's have the next slide. So the next slide is an example of a piecewise function. So what is this piecewise function? So if a function contains 2 or more formula, then it is under a piecewise function. So just like this kind of situation, that if in case you are a commuter and you want to ride a tricycle, so obviously during this pandemic times, the cost of riding a tricycle is 20 pesos. But that's the minimum amount. So in this case, you are going to pay 20 pesos for the first 5 kilometers. Okay, whether you will reach 5 kilometers or less, then you have to pay 20 pesos. But in excess of the 5 kilometers, you will have an additional of 75 centavos for the succeeding distance in kilometer. So how are you going to represent this situation as a function? So as I have mentioned, this is an example of a piecewise function. So obviously, this contains 2 formula. And what are those formula? The first formula is the 20 pesos for traveling 5 kilometers or less. Okay? And the second formula will be the basic fare, which is 20 pesos plus an additional of 75 centavos for every succeeding distance or in excess of the 5 kilometers. Okay? So, to do this, then the first situation will be f of d, where d is the distance, will be equal to 20 pesos if d is greater than 0 but less than or equal to 5. Meaning if you will travel less than a kilometer, then you still need to pay 20 pesos. That's why we have there the condition that your d must be greater than 0. Or else, if it will be equal to 0, then you don't have to pay, because that means you are not traveling. Okay? So just like, for example, if you will ride a tricycle from E-type of Quezon National High School going to 7-Eleven, then you still have to pay 20 pesos, even if it is that near. Okay? And the second formula will be the 20 pesos, which is the basic fare, plus 0.75 times the quantity d minus 5 if d is greater than 5. So let's say, for example, you traveled 7 kilometers. So you will not pay any more 20 pesos because that 20 pesos is basic for 5 kilometers. So in order for you to find how much you will pay if you traveled 7 kilometers, then it will be 7 minus 5 is 2. 2 times 0.75 is 1.5 or 150 plus 20 pesos. So you need to pay 21 pesos and 50 centavos for traveling 7 kilometers. So that's how we use this piecewise function in real life situations. Okay? Okay. So let's have the next slide. So the next slide has something to do with evaluating functions. But before you evaluate functions, you need to recall some of the different types of functions, and here they are. Okay, we have the constant function, the linear function, the quadratic, and the cubic. Remember that the types of functions are classified according to the degree of the given expression. So how do we determine the degree? The degree of a given expression or equation is the highest exponent used in the variable. So in this case, we do not have a variable, so that means the exponent here is 0. That's why it's a constant function. The exponent here of x is 1, so it's of degree 1, it's a linear function. The highest exponent is 2, so it's a quadratic function, and so on and so forth. So these are just some of the different functions that we had last week. So how do we evaluate function? So in evaluating function, all you have to do is to substitute whatever is the value of x given in the problem. So in this case, the given value of x is the 2x minus 3. So that means the 2x minus 3 here must be substituted on all the values of x. So if we will do that, then it will be, okay, replace x by 2x minus 3, then you have to square that. Okay, then minus 2, then replace x again by 2x minus 3. Okay, 2x minus 3, then the plus 2. Okay, so the next thing that you need to do is to expand this expression because you have the squared. Okay, so how are you going to do that? So I'm going to type na, excuse me for the way I wrote the expression. So squaring 2x minus 3, that means you have to multiply 2x minus 3 twice, or just use the 3 short steps in squaring a binomial, and that is squaring 2x. 2x times 2x is 4x squared. Okay, I do not have a function for the exponent, so we'll have like that one. Then 2 times 2x minus 3, the 2 here multiplied by 2x times negative 3, then it will be equal to negative 12x. Then you square negative 3. Negative 3 times negative 3 is positive 9. Okay. And then the negative 2 here must be distributed to 2x and minus 3. So you'll have negative 2 times 2x is negative 4x. Then negative 2 times negative 3 is positive 6. Then you have there the last term, which is 2. Okay. So as you can see here, we can combine similar terms like the negative 12x and the negative 4x and the 3 constant terms. So therefore, the final answer for f of x when x is equal to 2x minus 3 is f of 2x minus 3 is equal to 4x squared minus 16x plus 17. So that is how we evaluate function. And evaluating means you need to find the value. Okay? So let's proceed with the next one. The next slide deals with the different operations on functions. So what are those operations? We have the addition, multiplication, subtraction, division, and the last one is composition. And this example is under the composition of a function. So when we say composition, the value of a given function must be substituted to the first function. So since f of x here, that's the first order, and the second order is h of x, that means you need to substitute the value of h of x, which is x plus 2, from the f of x. Okay, so meaning all the x's here must be replaced by x plus 2. Okay, so how do we do that? So we will have the composition. We do not have the function for that, for the composition, the circle. So the composition of f and h of x will be equal to, replace x again by x plus 2. So x plus 2, then squared, because of the square here, plus 5 times x plus 2, then plus 6. Okay, so just like what we had with the previous slide, that you need to square x plus 2. And squaring that means multiplying x plus 2 twice.
So that will be equal to x squared plus 4x, because you need to multiply the 2 outside, exponent 2 to 2x and to 2. So 2 times x is 2x times positive 2 is positive 4x. Then you square 2. So 2 times 3 is equal to 4. Okay, then plus, you distribute 5 with x. So 5 times x is 5x plus 5 times 2 is 10. And the last one is plus 6. Okay, so with this one, we can combine the 4x and the 5x because they are similar terms. And then the 3 constants again. Okay, so combining that, therefore, the composition of f and h of x is equal to x squared plus 9x plus 20. Okay, that's the composition. So I hope last week's topics are clear to you already, and we can now proceed with this week's topics. So the first topic for this week is all about rational functions, equations, and inequalities, and we have the following objectives. Represent real-life situations using rational functions and distinguishing rational function from rational equation and rational inequality. Okay. First, what do you mean by rational functions? Hearing the word rational. Okay, so from your junior high school math, when we say rational, it is an expression of the form Q over P or P over Q. Okay, or it is a quotient of two expressions. So here, when we say a rational function, it is r of x, that's the symbol for rational function, is a function of the form r of x equals p of x over q of x, where p of x, the numerator, and q of x are polynomial functions. Okay, so it can be a linear function, a cubic function, or a quadratic function, or a constant function. And q of x is not equal to 0. Why? Because once your denominator becomes 0, then the whole function will be undefined. So as much as possible, do not make your q of x or your denominator equal to 0. Okay? And then the domain of r of x is a set of real numbers such that q of x is not 0. Okay? So take a look at these examples. Which do you think is not an example of a rational function? Is it the first one, the second one, the third, or the fourth? If your guess is the fourth one, then your answer is correct. Okay? So this is not an example of a rational function. Why? Because the first considerations to look for are the exponents. In a rational function or in a rational expression, the exponents must all be positive. No negative, no fractional exponents, and no radical expressions. In this case, the numerator contains rational or radical expressions, rather, the square root symbol. Okay? So that's why the fourth example is not an example of a rational function. Okay? Now let's try to represent real-life scenarios or real-life situations as a rational function. Okay? The local government unit allotted a budget of 100,000 pesos for the feeding program in the daycare center. The amount will be divided equally to all the pupils in the daycare center. Write an equation showing the relationship of the allotted amount per pupil represented by f of x versus the total amount of children represented by x, or total number of children. So how do we do that? Of course, if you have a certain amount of money, for you to divide that to the number of pupils or children in the daycare center, whatever is the number or how many children are there in the daycare center, you need to divide that by 100. So let's say, for example, there are 100 children, then it will be 100,000 divided by 100. Okay? But since it's a rational function, and a function must be an equation that can represent any situation, meaning whatever is the number of children in the daycare center, then that will be your formula. And to do that, then this problem will be represented by the rational function f of x is equal to 100,000 divided by x, where x is the number of children. Okay? Okay, let's try. Let's say, for example, we have an extension of that problem. From the 100,000 pesos allotted by the government, a certain benefactor, okay, somebody who has a good heart, wants to supplement the budget allotted for each child by donating additional 650 pesos per child. If h of x represents the new amount allotted per child, construct a function representing the relationship. So from the previous expression, that what we had a while ago, the 100,000 divided by x, there will be an additional of 650 pesos per child. So from the expression we had, then it will be h of x it will be h of x is equal to 100,000 over x plus the 650 allowance or supplemented by the benefactor. So again, this is an example of a rational expression, though we have added the 650 here. Okay? Another one. Taking into consideration the formula for velocity in this problem. Okay? So how do we recall, or what's the formula in finding the velocity? Velocity is equal to displacement over time. Okay? So the displacement or the distance with direction is 70 kilometers. Since we do not know yet the time, which can be represented in general by t, then the velocity will be equal to 70 over t, where v of t, the velocity, the function v of time is equal to 70 divided by t. Okay, that's actually the formula. Okay, so those are all about the rational functions. But about when we say the rational equation. So as we define rational equation, it is an equation involving rational expressions. And please take note that if there is an equal sign, then more or less it can be considered as a rational equation. But look at this example. Okay, what makes the difference of this with what we had a while ago on rational function? Because a rational function contains also an equal sign, right? Okay, but to distinguish whether it is a rational equation or a rational function, look at this example. How many variables can you see from this? We have only one variable, which is x. Okay, so that is in the case of a rational equation. But in the case of a rational function, if there is f of x or a variable y in either side of the equation, then it is a rational function and not a rational equation. Okay, so that's the distinction between the two. How about the rational inequality? Okay, so as the name suggests, there must be an inequality symbols. And what are those inequality symbols? Symbols like not equal to, greater than, less than, greater than or equal to, and greater or less than or equal to. So those are the symbols that you have to look into for you to classify if the given is a rational inequality. So as we defined, a rational inequality is an inequality involving rational expressions, like this example. So this is an example of a rational inequality since we have the symbol greater than. Okay, so let's try practicing. I have here three expressions. Now, how will you classify the first, the second, and the third? So which one do you think is the rational function? Okay, you're correct. The second example is an example of a rational function. Which one is the rational equation? And you're correct. The first one is a rational equation. And lastly, of course, the rational inequality is the third one since it involves the greater than or equal to symbol, right? Which is the inequality symbol. So we can now distinguish the difference among these three. Let's have lesson 3 for this week. Lesson 3 for this week is about solving rational equations and inequalities. And actually, for you to be able to solve rational equations and inequalities, you must try to recall how to factor polynomials and how to get LCD. Okay, and these are the objectives for the third lesson. You need to apply appropriate methods, and that is what I had mentioned a while ago, the factoring method. The different special products method. Okay? Then you need to solve the rational equations and inequalities using algebraic techniques. And lastly, you need to determine whether the solutions found are acceptable or not by simply checking your solutions. Okay. Let's try the first example on rational equation. 2 over x squared minus 1 over x minus 1 is equal to 1/2. The first thing that we have to look into is that are there expressions which can be factored? And the answer in this case is yes. There is still one that needs to be factored, and that is x squared minus 1. So what special product is applicable for this denominator? You still remember difference of two squares? The x squared minus y squared expression. Okay? That if you have difference of two squares, the factors will be two terms. One is plus sign and the other is minus sign. And whatever is the first term, you need to find the square root of that, also the square root of the second term, and that will be the terms of your factors. So this case is under this type of special product. So meaning, if we will try to rewrite this with the factored form already, then it will be 2 over, and make it longer, x minus 1 times x plus 1. Okay, so that's the factored form of this. Minus 1 over x minus 1 equals 1/2. Okay, so after considering all expressions which are factorable, then the next thing to do is to simplify. And how are you going to simplify that? By looking at the LCD, or the least common denominator. And what is the LCD? What sides of the expression? Of course, we have the 2 coming from here, and then the x minus 1 coming from here, and 1 here, and the last one is x plus 1. Okay, so that's the LCD, the least common denominator. And after knowing the LCD, you need to multiply both sides of the expression, or both sides of the rational equation, by that LCD in order for you to simplify. So if the first term will be multiplied by this, we can cancel the x minus 1 and the x plus 1. And what is left is the 2. So that 2 must be multiplied to the numerator of the first term. Okay, so you have there the 2 coming from the remaining 2 here, and the 2 in the numerator, minus the numerator here is 1, so we need to write that. If this x minus 1 will be multiplied, or if this LCD will be divided by x minus 1, the x minus 1 will be cancelled, and what are left are the 2 and the x plus 1. And we're going to multiply that with the numerator 1. So 2 and then the remaining x plus 1. Okay, equals. Okay, dividing this, the LCD by this, we can cancel the 2. And what are left are the x minus 1, x plus 1. We can write at once the product of this, bringing back the x squared minus 1. Okay, so we have multiplied these two. Okay. Then, the next thing to do is to simplify. Okay, so how are you going to simplify? I'm going to use the text already. Okay, so we have 4 minus 1 times 2 times x is negative 2x, then negative 1 times 2 times 1 is negative 2, equals x squared minus 1. Okay. Okay. And then what's next? Next is to equate the rational equation to 0, meaning you need to transpose all these terms, the 4 minus 2x minus 2 on the other side, okay? And that will make us, or it will give us x squared. Transposing negative 2 will make it positive 2x. Then the negative 1, 4 will be negative 4, and the negative 2 will be positive 2, equals 0, because we need to equate, okay? So as you can see, all these terms, the 4, negative 2x, negative 2, we change all their signs. The positive 4 becomes negative 4, the negative 2x becomes positive 2x, the negative 2 becomes 2, okay? Then let's combine. You'll have x squared plus 2x minus 3 equals 0. So that's the simplified form, okay? And then this is actually a trinomial. The x squared plus 2x minus 3 is a trinomial which can be factored. And what are the factors of that? We have x plus 3 and x minus 1 equals 0. So how do you get the factors of a trinomial? It's a matter of trial and error method. But of course, in this case, all you have to think is to get the factors of negative 3. When we say factors, you need to think of two numbers which when multiplied will be equal to negative 3. And those are positive 3 and negative 1. Why not negative 3 and positive 1? That will also give us a product of negative 3. Still, you need to consider your middle term, which is positive 2x. Okay? If you will see 3 minus 1 is positive 2, and that will be the numerical coefficient of your middle term. So that's why it's more proper to use or correct to use positive 3 and negative 1. Okay? Then after that, each factor must be equated to 0. The x plus 3 will be equal to 0, and x minus 1 will be equal to 0 for us to find the value of x. So with x plus 3 equals 0, then the value of x will be equal to negative 3, and the other one for x minus 1, then x will be equal to positive 1. Okay? So do you think if we have two values of x, it will be okay for the given rational equation? Okay. So if you can still remember with the objectives, we need to check our solution, meaning we have to see whether it is x equals negative 3 or x equals 1, the correct solution for the given rational equation. And how do we do that? From this, the original equation, we need to substitute it one by one. First, let's substitute, or let's have when x is equal to negative 3, what will be the result? Okay, so here, replacing x by negative 3, then we need to square. It will be negative 3 times negative 3 is positive 9, and 9 minus 1 is 8. So meaning for the first term, we'll have 2 over 8. Then, okay, try to replace the x naman on the second term by negative 3. You'll have negative 3 minus 1 is negative 4. So you have 1 over negative 4 multiplied by the negative sign here. You'll have plus 1/4 equals 1/2. Okay? If you can see, here, 2 over 8 can be simplified. And what's the simplified form of 2 over 8? That is 1/4. So meaning 1/4 plus 1/4 is equal to what? That is equal to 1/2. So 1/2 on the left side, is it equal on the right side, which is 1/2? Yes, it's equal. So what does it mean? That x equals negative 3 is a solution. But how about this x equals 1? If we will try to substitute when x is equal to 1, then it will make the rational equation 2 over 0, because 1 squared is 1 minus 1 is 0, minus 1 over 0. Remembering the definition of the rational function, where your q of x must not be equal to 0. Why? Because this will make the expression undefined. Okay? And undefined is not actually equal to 1/2. So what does it mean? It only means that x equals 1 is an extraneous solution. Okay? So it's very important for us to check if you have more than one values of x. Okay? So the only solution for this rational equation is x equals negative 3. Okay? Is that clear to you? Okay. So we can now proceed with rational inequality. Say we have 3x plus 1 over x minus 1 is greater than or equal to 2. Okay? In the case of rational inequality, the first thing that you have to do is to combine all terms on one side of the equation. Okay? Meaning the 2 here must be transposed on the left side. So we will have 3x plus 1 over x minus 1. Okay, transposing positive 2 will make it negative 2 is greater than or equal to 0. Okay? And after equating the given rational inequality to 0, the next procedure or the next step is to combine the rational expressions, meaning we're going to combine this. And how are we going to combine? We need to find the LCD. And what's the LCD? It's x minus 1. Okay? Still, it's greater than or less than greater than or equal to 0. Okay. Of course, dividing this LCD with x minus 1 is 1 times 3x plus 1 is still 3x plus 1. Okay. Then since the second term does not contain a denominator, then it will be minus 2 times the LCD, which is x minus 1. Okay. Then simplify now the numerator. You have there the 3x plus 1. Then multiply negative 2 with all the terms inside. So you have negative 2 times x is negative 2x. The negative 2 times negative 1 is positive 2 over x minus 1 is greater than or equal to 0. Okay? Now we can simplify now the numerator. Combining 3x and negative 2x is x. Then 1 plus 2 is 3. So x plus 3 for the numerator, and the denominator is x minus 1. Once you're done simplifying or combining the rational expressions on just one side, the next thing, if it is already in simplified form, is to equate both the numerator and the denominator of the rational expression to 0, meaning the x plus 3, which is the numerator, is equal to 0, and the denominator, which is x minus 1, equals 0. Yeah. So finding the value of x, you will have x equals negative 3 and x equals 1. Same with what we had with the previous example, but this one is quite different. Okay, so that means the possible solutions of the given rational inequality are negative 3 and 1. And if we're going to plot that on the number line, then it will look like this one. Here's the negative 3, negative 2. In a number line, number line. 1, negative 1, 0, and then 1. Okay, and as what we have solved, the solutions are just negative 3 and 1. Okay, so we have to check whether the negative 3 and the 1 are really the solution of the inequality. And how do we do that? We will try to substitute x equals negative 3 from the given rational inequality. And when x is equal to negative 3, you will have 3 times negative 3 plus 1 over negative 3 plus 1 is greater than or equal to 2. Okay, let's simplify. What is this? What's the value? Then 3 times negative 3 is negative 9 plus 1 is negative 8 over negative 3. Sorry, for the denominator, it's negative 3 minus 1. Negative 3 minus 1 because of this. Okay, negative 3 minus 1 is negative 4. And what is negative 8 over negative 4? That is equal to 2, right? Is 2 greater than or equal to 2? Yes, that's correct. So meaning negative 3 is a possible solution. Okay? Now let's have x equals 1. When x is equal to 1, what do you think will be the value of our expression? So we will have 3 times 1 plus 1 over 1 minus 1. What do you think will become, what will happen to the denominator of your fraction? 1 minus 1 is 0. And if the denominator is 0, then that means it becomes undefined. And is undefined greater than or equal to 2? Well, it's not. So that means 1 is not included in your solution set. Okay? How about, what do you think with negative 1? So let's try substituting that with our expression. I just to check whether in between the negative 3 and 1 are part of the solution set. When x is equal to negative 1, what will happen to our expression? Say 3 times negative 1 plus 1 over negative 1 minus 1 is greater than or equal to 2. What is 3 times negative 1? It's negative 3 plus 1 is negative 2 over what is negative 1 minus 1? It's negative 2. Greater than or equal to 2. And what is negative 2 divided by 2? Negative 2, that is, okay, it's positive 1. And looking at that one, is positive 1 greater than or equal to 2? Yes, that is not correct. So meaning negative 1 is not part of the solution set. How about when it is 0? What will happen to this? So 3 times 0 is 0 plus 1, we have 1. Then 0 minus 1 is negative 1. What is 1 divided by negative 1? It's negative 1. Is negative 1, okay, when x is equal to 0, is negative 1 greater than or equal to 2? Again, it's wrong. Okay. Now let's try substituting all numbers to the left of negative 3. Let's say, what if x is equal to negative 4? What will happen to this? Okay, substitute x equals negative 4. So we have 3 times negative 4 is negative 12. Plus 1 is negative 11 over negative 4 minus 1 is negative 5. Is it greater than or equal to 2? What is negative 11 over negative 5? That is positive 2 point something, right? So 2.222. 10. Okay, yeah. It's 2.222 and obviously 2.222 is greater than 2. So that means if negative 4 is correct, which is on the left side of negative 3, probably all numbers to its left, to the left of negative 3, will be part of the solution set. Okay? How about to the right of 1? Say we have x is equal to 3. We will substitute that value from here. We'll have 3 times 3 is 9 plus 1 is 10. Over 3 minus 1 is 2. Is greater than or equal to 2. What is 10 over 2? 10 over 2 is 5. Is 5 greater than or equal to 2? Yes, that's correct. That shows, it only shows that all numbers to the left of negative 3 and to the right of 1, excluded 1, are part of the solution set. So how are you going to write the solution set of this rational inequality using the interval notation? Okay, so the solution set will be, yeah, we're going to use the parentheses. Remember, when we use the parentheses for interval notation, it means greater than or less than that value is included in the solution set. And if we use the bracket symbol, that means it's part of the solution set. Okay, yan, up to infinity. Okay, so again, to recall that, when we use parentheses, it represents solutions greater than or less than the number. So greater than or less than the negative infinity are part of the solution set. But if you use the bracket, it represents solutions that are greater than or equal to or less than or equal to the number. So meaning up to negative 3 lang siya. Okay? So this is the final answer for this rational inequality using the interval notation. It's quite long to solve rational inequality. Okay? So let's try to proceed with the next lesson. The next lesson is about representations of rational functions. And for us to represent rational functions, you must have the table of values, the graphs, and the equations. Sometimes equations are excluded already because if the given is an equation, then all you have to do is to have the table of values and then the graph of it. But if the given is a problem, then you need to represent that using these three. Okay. And when it comes to graphing your rational function, you can use GeoGebra or Desmos, whichever is or which of the two is convenient to use for you. Okay. Or which one is easier to use. Okay. So in the case of that, we need to recall this. Okay, that in any rational function, it's always in the form of this, where both p of x and q of x are polynomial functions, and that the denominator must not be equal to 0. Okay. Let's say we have this. F of x is equal to x over x plus 2. Okay. As you can see in the denominator, the domain, okay, let's try to go back to this. As mentioned here, the domain of all values of x where q of x is not equal to 0, okay? Or the denominator or q of x should not be equal to 0. So we will try to make use of 5 values, okay? And I have here set that x must be from -2 to 2. If x is equal to -2, then it will make the function undefined. If it is -1, then we have -1 over -1 plus 2. So we have -1 over +1 is still -1. And then when x is equal to 0, it is equal to 0 because 0 over 2 or 0 divided by 2 is 0. Then if x is equal to 1, then the function f of x will be 0.333. And if x is equal to 2, then f of x is 0.5. Okay? So this is already the table of values. And how are you going to graph that? Okay, so we'll stop sharing for a while. Okay, so this is my daughter. Okay, so we'll try to make use of the GeoGebra. Okay, so in the GeoGebra, as you can see here, there's already the grid. Okay, wait, it's still loading. Yeah, so these are the grid by which the graph will be reflected. Okay, so you can type already the given function, the rational function, y equals, so there are 2 ways of doing that. One is by typing the original rational function, or you can type the ordered pairs in the table of values that we have set a while ago. So if we will try to type the given rational function, y equals, what's that? X over, is it x plus 1? X plus 2, right? Yeah, x plus 2. Okay, and then of the given rational function. Okay. 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 If you can still remember with the table of values, if we have set x is equal to -1, what's the value of our y? Okay, it's -1. Okay, it's right here on the graph. Okay. If x is equal to 2, the value of our y is 0.5. Here it is. Okay. Okay. So this is how we graph a given rational function. So you must know how to use the GeoGebra. If not, so from the table of values, okay, let's make use of that. From the table of values, we're going to input. Yan. Diba we have there 1 and then -1. Okay. And then 0, the value of y is 0. And then, what's the x? I know. This one is, okay, that's correct. When x is -1, -1, -1 also. Okay, I think this one is, if it is 1, then it's the value 0.333, right? Okay. And then another one is if x is equal to 2, then our y is 0.5. So there are two ways of doing that. And as you can see in the graph, yeah, these are the points which are on our table of values. Okay. Okay, so let's go back with our PowerPoint presentation. So here are those points that we had a while ago. Okay, so I hope you learned on doing or using the GeoGebra. So that's how we represent, that is how we represent rational function. Since it's already the equation that is given, so we only need to represent this using the table of values and the graph. Okay, let's proceed with the last lesson, which is how do we find the domain and range of rational functions. So these are the objectives. We need to define what our domain and range is, and then find the domain of the rational function. So we all know that when we say domain, these are actually the values of the set of values of the x variable. And the domain is also known as the independent variable or the input, while the range is the output. That will be the value. Okay. The range is the y values, the dependent variable. Okay. So recall that there are different ways by which we can write the domain and range. One is using the roster format or the roster method, in which the roster method entails using or needs to list down or enumerate all the values of your domain and your range. So using the braces, and then each value must be represented or separated by a comma. That is by using the roster method. The second one is using the set builder notation or set builder form, which makes use of the expression x such that x. Okay, the restrictions. So that is for the domain and range actually. Yeah. And the last one, the one I used with the example that I had for the rational inequality, which is the interval notation. So in the interval notation, you will set that the limitation of the values of your domain and range. Okay, so again, it depends on the direction of the problem, whether to use the set builder, the interval, or the roster form of your domain and range. So let's try this one. Find the domain and range of the rational function f of x equals x minus 5 over x plus 2. So here are the steps of doing that. So for the first method, we need to determine the domain. And how are you going to do that? First, you need to equate the denominator to 0. And which one is the denominator? It's the x plus 2. So doing that, we will have x plus 2 equals to 0. So transposing 2 on the other side, then x is equal to -2. So meaning your domain is the set of all x's such that x is an element of the set of real numbers and x must not be equal to -2. Meaning the solved value of x is your restriction. Because once this value is substituted from the given rational function, then it will make the rational function undefined. That's why we have here x should not be equal to -2. Okay? So that is how easy the way we find the domain of the given rational function. How about finding the range? Okay, so for the range, the first thing to do is to replace f of x by y. So in doing that, we will have y equals x minus 5 over x plus 2. And from that, yeah, we need to multiply the denominator on the right side to y. So in doing that, we have y times x plus 2 equals x minus 5. So we need to distribute y inside the parentheses. We'll have y times x and then y times positive 2. So you'll have xy plus 2y equals x minus 5. Then you combine all the x's, all terms with x, put that on the left side. So you will have xy, then minus x equals -5 here. Then we have transposed the positive 2y, making it -2y. And from here, we can, how do you call that, factor out x. Since x is common to the two terms, then it will have x times y minus 1. So if you will divide xy by x, we can cancel x, and what is left is y, and then dividing x by x is 1. Then the right side will be this one. Then solve for x. Okay, solving for x, the y minus 1 must be divided on both sides of the equation. Okay, telling us that we can cancel out the y minus 1. So what is left are x equals -5 minus 2y over y minus 1. And from that, you need to solve the value of your y in the denominator. And what's the denominator? It's y minus 1, therefore y is equal to 1. So that is again a restriction. So meaning the range is the set of all y such that y is an element of the set of real numbers and y must not be equal to 1. So using the set builder notation, then the given function f of x equals x minus 5 over x plus 2 has the set of domain and range as this one. Okay, so any question on that? I hope none. Okay, so good luck on your written output number 2, because the written output number 2 deals on finding the domain and range of the given rational function. So that's all for this week. Thank you for listening, and I hope you enjoyed our lesson for week